So this equation here is definitely used of the conjugate root theorem, because a polynomial is given, one of the solutions is given, the polynomial has no I, so there is no imaginary, but the solution has is a complex number, so that means the second solution would be the conjugate of that. So that's the first thing you would write. Z equal 3 plus I, so the other set will be 3 minus I. Then you would rearrange to write it as equal to 0. Then you would expand so expanding this, I'm just writing the expanding in here, so just multiply each term. Very easy to make mistakes in here, so you just need to be very careful in your expanding. Minus 3i, and then minus zi, I'm just multiplying, plus 3i, and then I times I is negative, and plus another negative, so it's plus 1. Now cancel out, so z square is here, 3z and 3 minus 3z minus 6z, then positive zi with negative zi will cancel out, and then I will end up with plus 10. So that's the expanding for this one. You would know that your expanding is correct if there is no I. If there is an I component left, that means you've done a mistake. You've done some sort of mistake in your expanding. Now the next step, you would say, all right, so this was one of the factors. That has two factors in here, so you need to find the other factor. The other factor definitely has 2z, because I've got 2z to the power of 3. This is only z square. I have 2z in here. Okay, and you need to be multiplied. The constants needs to be multiplied to get 30. So negative 3 definitely in this case. Therefore, the other factor would be z equal 3 over 2. So that's your third solution. So you've got 1, 2, so that's the first solution, second solution, and that's your third solution. Now you have two ways to go by this. You either expand and compare, and that you will find the p, or you will do the long division. Okay, so I'm not going to do the expanding because you all know how to expand. So I'm going to do the, not the long division. You will have to expand and compare, or you can substitute. If you substitute the 3 plus I in here and solve, you will get the value of b. So if I substitute, those three terms, you can enter them straight away in the calculator, and that would give you the answer. So now if I enter them in the calculator as they are, I'll get the answer of negative 114 minus 38i plus 3bi plus bi equals 0. 3b plus bi. Now you should know how to enter that in the calculator by just going to menu, run, then you go options, then you choose complex, which is F3, and that will give you the I, and you enter it exactly as it is. So 2 open a bracket, 3 plus I close bracket to the power of 3, and so on and so forth. Only those three ones that I've highlighted, underlined. And now solving this equation, you would rearrange and imaginary equal imaginary and real equal real, so that therefore b will equal 38, and that's your second part of, because there is two answers in here. So you can find the b by substituting, or if you expand this one here and compare back, you will also find the b. stopping.